Thanks a lot. First of all, thanks a lot for inviting me, and I hope you had a good day. I've been actually following many of the talks, and I have to say it's been for me a fantastic experience. Some great some great speakers, and actually fantastic chat discussions as well. And talking about chat, I've been told that we are giving away 5 copies of CloudFormation on AWS. So if you're really active on the chat and you ask questions, we'll be giving some copies. So feel free to be active. So today I'm going to talk a little bit about a complex system, outages, and chaos. And before actually starting, I want to ask you a question. Do you want to lose $100,000? So if you do, please tell your name on the chat, because I'd be surprised you won't, right? So why I'm asking this question is it's because that's the average price of 1 hour of downtime, actually, and that's okay. Okay, so
and I don't want to lose $100,000. So
okay, cool. So at least you heard me talk about the $100,000. So yeah, so that's the average time of 1 hour of downtime. So I guess a lot of what we need to do is trying to avoid that. And that brings me to talk about a little bit availability of complex systems and distributed systems, and actually systems in general. And we calculate the availability by the normal operation time divided by the total time of operation, or by the time that it takes between failures divided by the time between failures plus the time to recover. And that gives us one very important information is actually, if we want to have a maximum availability, well, we need to have MTTR close to 0 so that we can have 1 over 1, which then will give us close to 100%. So that gives me an important thing to think about. And MTTR is very important during an outage, right? So if we look at the anatomy of an outage, we typically have something like this, right? We have the time, we have a failure, and then there's the moment of detection, evaluation, a response, hopefully a response, some recovery, a confirmation that things are good, and then eventually an all clear. Of course, each of those phases is very different between outage. Right? You can have a very long detection, sometimes a very fast response, or a very long one. So the point here is I want to draw the curve of stress, and that's human stress related to this. And as you can see, the stress level goes very, very fast as soon as we have a detection. So that means like, okay, we know we have an outage, and eventually it stays up until the all clear. But actually, in many companies that I've worked with or operated in, sometimes at all clear, then there's stress level goes back up, and usually that's because we have companies that have blaming cultures, and then we are scared of being fired. So in the early days of my career, I remember that I had a very big outage, and I was not trained to recover from outages. And I had it was Sunday afternoon, a very terrible outage, several hours down, and like the whole company starting to fall apart. Everyone started to yell, and I ended up actually creating even more problem and deleting a database in production. So it took even longer to recover. And I can tell you at the end, my stress level when we all recovered actually didn't go down. It actually went up, because I was really wondering what was going to happen to me. But luckily, my manager never ever pointed the finger to me, and instead asked me what we can do to not repeat this ever again. So for me, this is a very important lesson. And from the outage, actually, we can then deduct what we call the time to recover. And of course, time to recover is very important, because the faster you recover, the more available you are for your customers. And the more available, the less you're going to have customer churn. So if we think a little bit about MTTR, there is actually quite a big problem with that metric, and I want to address this. So if I give you this slide and I ask you which of the best of the two company is the best, you probably would tell me, well, of course, MTTR is best for company number 2 because it's lesser. But if I add this information into into the picture, things start to get a little bit more messy, because now we have the same company that had a low MTTR but has 33 outages per month. And if you accumulate the number of hours, it's a lot worse, right? So here MTTR is indeed lower, but actually company number 2 obviously has much bigger operational problems. So when we think about MTTR, it's very important to understand what we're talking about, right? The mean part of MTTR is actually the problem. So if you think about MTTR on the system-wide, it really gonna be a problem. What we want is to think about it in terms of different class and type of outages. It's also very important to set some recovery target time so that we can then include this into the MTTR document, right? And eventually also include the total number of incidents and cumulative incident time. Okay, so now we've dealt with the time to recover. We understand the problems of the mean and we classify them. So how do we actually improve the time to recover? And typically there are four areas of work, right? You can design your system for resiliency. You can detect better, you can recover faster, and also continuously improve. And this is very important that we look into all this. So the first one is design for resiliency. And one of the big problem I see is when people talk about complex system, they automatically think about the Amazon, the Twitter, the Netflix. Yeah, there's like hundreds of, sometimes thousands of microservices. And indeed, those are really complex distributed systems. But actually, this simple client network server diagram is also a complex systems, because there are a lot of places here that can go wrong, right? Your client sends a message to the network, then the network passes it to the server replies, and then the network replies to the client. And at each of those steps, you can have some errors. And typically, you actually often can have these errors. And this is why we have different type of network error, latency, error codes, or sometimes also packet loss. So, I mean, inherently, all the systems are complex. It's not, doesn't have to be distributed. Monoliths are actually also very complex systems. So when we talk about building for resiliency, it doesn't necessarily have to think very far in terms of distributed systems, because I'm pretty sure if I ask you in the audience how many of you have had certificate expiration type of outage, I'm sure a lot of you are going to raise hands. And the same, how many of you have had outages that were due to deployments, right? So this is the kind of kind of readiness list. It's a very simple one, but it's just to give you some things to think about when we design for resiliency. And then there's something else as well, like you can't infinitely design for resiliency, because it's really is hard. Like you maybe at the beginning you get a lot of bugs for your work, but eventually you're really going to have to invest a lot of time to get closer to the 4 or 5 nines of availability, right? So it's not proportional. It's actually the work is exponential in terms of need to get your nines of availability. Then there's another thing that we start to talk about as well is, and actually many people have talked about in the presentation. And this is what we call partial failure mode. And I think this is the best video I've found to explain the thing is, okay, you have a system, but instead of having a binary system that works or doesn't work, you want to have some graceful degradation. And this is totally part of resiliency. And you know, how you can design a system that accepts failures, because failures happen all the time. If you don't embrace failure, and if you don't think about failure as a first-class citizen, basically you're gonna have bad surprises. So thinking about partial failure mode, and especially how you're going to degrade, hopefully gracefully, is something that is also very important. When you are building resilient system, most of the time people think about infrastructure, network, data, and application layer. But actually, there's a lot of things to think about as well in terms of resiliency, in terms of operation. And we talked about the deployment, but we also think about railguards, and how do you actually operate safely in the system? How can you make sure that when you are operating in production, you don't run drop table in production like I did. So I didn't have the right environment. I didn't have the right tools or the right notice, and I could do things that were actually very dangerous. And finally, there's also thinking about people, because I work with a lot of teams where there is this hero in the team that knows pretty much everything, that's been in the company for long, and he has secret sources that sometimes he doesn't share with the company. So this is what I wanted to really make sure that when we think and talk about resiliency, we don't only talk about the technology, but really also about how people think and operate safely. The second part of improving MTTR is, of course, detecting better. And to detect better, I've never found anything better than find a way for any developer in the company to actually only write one line of code to be able to do any tracing, measuring, and actually graph something. If it's more complicated for a developer, generally they won't do it. If you really have to import a lot of things, write a lot of code to start measuring a particular metric, usually people don't do it. So if you make it easy and invest in making it easy, generally you're going to have good metric, and good metric means that you detect better. I don't know, I don't count anymore how many outages I've had that didn't have the right alarm, or we were not measuring the length of a queue or the latency on the particular database or something like this. So the main problem is it just was not easy enough for people to write those metrics. And also when you start looking into debugging things, right, and you start to want to put some metrics in place and instrument your code, make it as easy as possible. I've talked about alarms. I mean, if you don't have the right alarm, generally you will not detect. So we do this for fire alarms in the home. So this is something that you really, really need to focus on as well, and test your alarms regularly. Never assume that your alarm works. If you assume something and if you haven't verified regularly that your alarm system is working, assume it's broken. And that's the same for backups, by the way. I think a lot of people assume to have backups, but a backup is only valid really when you have proven that you can recover safely out of it. And the third part is recovering faster. And to recover faster, I want to take an example of firefighters. Firefighters spend approximately 80% of the time to practice going into fire. And they do this to really build an intuition so they don't have to think when they go and fight a fire. And I can ask you as well, how many of you have practiced recovering from an outage in the last week or in the last month? If you haven't done in the last months, you're going to have skill atrophy. That means you're not going to be very, very skilled or fluent with different tools and command line Linux tools to do your debugging and to do the inspection of the problems in the outage. right? In the early 2000s, we actually hired a firefighter, a volunteer firefighter called Jesse Robbins, who prepared what we call the game day at Amazon. And a game day was already in the early 2000s, a moment where we would practice actually recovering from outage. So what you typically would go, you go around the data centers and unplug things or inject faults. And that was really to improve the resiliency, but also the incident response of his team. It was a master of disaster. I think it's probably a life goal. Once you achieve this, it's pretty cool. And then we come to chaos engineering. There's, very interesting talk earlier today from Netflix around chaos engineering. So I don't want to deep dive too much into it, but chaos engineering is a scientific method, and it's a way to experiment on the system where you make an hypothesis and you go into trying to prove or disprove this hypothesis. It's like, for example, can my system still operate without the master database? Can we actually turn into a read-only mode? This is the kind of hypothesis you would go into trying to prove or disprove in the system. And what is very important with chaos engineering is, of course, people think it should be done in production, and the goal is eventually to be done in production. But what is very important is to start the journey. You can't start in production, so you really have to learn to do it in your local environment, get comfortable with the tools. It's all about building confidence, right? And I've never seen anyone get confidence by starting in production. So even though I usually don't make friends when I say like start chaos engineering outside of production, but I think, and I've seen with customers, it's really, really the safest way to do this. And eventually it has the teams build confidence in their capacity to recover and to identify mistakes in a live production environment. Definitely it's something that will eventually move to production. And we do chaos engineering really to avoid having weaknesses appear in production at 3 a.m. or during Christmas and birthdays. And these are outages that I've had many appearing during this time. If you want to read more about chaos engineering, actually Netflix published probably the best book around that. There's a link in the slide. So go have a read, definitely. And the good thing is actually Spinnaker does integrate very well with chaos engineering and with another concept, which in my opinion is very important when you want to learn how to recover fast, is the concept of immutable infrastructure, where instead of doing replacement in place, you actually do a replacement using a canary pattern. That same canary pattern is actually used to do safe experiments for chaos engineering. So if you're using Spinnaker, if you're interested into chaos engineering, Spinnaker does support canary patterns. So definitely also try to embrace and look at it, because it really, really helps with your recovery. And lastly, I want to talk about.
Oh, go ahead.
Yeah,
we got to wrap up here, Adrian, and I have a note on the questions, but keep going. I'll let you wrap up because we want to hear this.
Okay. Yeah, I'll try 2 minutes. Is okay? Is all
right? Sure.
All right, cool. Sorry about that. So in terms of continuous improvement, spend a lot of time on your postmortem. We talked a little bit about postmortem today. What is very important is that there is actually no isolated cause of accident. It's usually what I see the most common mistake is people find one cause and then they stop there. Actually, there are many causes for an accident. So try to investigate these, and especially don't stop at the operator. Don't stop at the person, because everyone has good intention. You don't come to work with thinking today you're going to do a really bad job. So if you stop and you find yourself blaming someone, it's more because you have some biases that you need to go through. So when you try to look at causes of an accident, I always suggest to look into 3 areas: the culture, the processes and the tools, right? And this is really, really important for you to do that. And finally, in my lesson learned, and this is not technology lesson learned, and I really have two that I want to give you maybe some suggestion for you to go and learn more about it. It's called the normalization of deviance, and this is stuff we do regularly that. If you would go and visit another company and a team, you probably would find very dangerous. But because we've done it for many years, we get really used to it. And these are usually things that eventually turn into an outage, like logging into a live production system using SSH, these kind of things without, a good safeguard. It might be stuff that we do and if we've done successfully for years, but this is exactly what the problem is. It's become normal, and we don't treat it as something that actually can be very dangerous. And then watch out for heuristics, right? The sunk cost fallacy, confirmation bias, and of course, my favorite one, the fundamental attribution errors, which is often the problem that is used in postmortem to blame people. So have a look at those. And remember that technology really never, ever makes any system resilient. It's really the people around the team that does. So shift the focus from technology to people, and trust and enable the people. And then I can assure you, you'll be successful. And thank you very much for your time. And I'm so sorry that I took more time.
No. It's so good to have you, Adrian. And I have already volunteered you to do something else for us because of this. Okay. There were some great questions in the chat, and awesome. I recorded them all before they disappeared. So what I would like to do is invite you to join me on an episode of the Continuous Delivery Foundation's podcast called The Pipeline. We can do the recording hopefully here soon. So I'll reach out to you about it offline, but look for my announcement in Spinnaker Slack, everybody, and on Twitter. It's on the Spinnaker Twitter. So you can see when we are going to follow up this conversation, and we're going to focus that session on your questions so that Adrian, can take the time to answer those. Thank you so much for joining us today, Adrian. Thanks for joining us.
Thank you very much for inviting me. And it's been a fantastic day and very well organized. So congratulations.
So happy to have you. We're honored. Bye-bye. Bye, Adrian.